In this video, we're going to take a look at irrational numbers. In the last section, we looked at rational numbers, numbers that could be written as fractions. Now we're going to look at irrational numbers. So these are the decimals that go on and on forever without ever repeating. So it might be something like, 5.1234567876235 so on and so forth. So never terminate. So these are numbers that are given to us when we're dealing with square roots. So the square root or a radical sign, okay, is what we're going to be taking a look at. To kind of spear point the conversation on this, we can say that 2 squared is 2 times 2, which is going to equal 4. If I look at what the square root of 4 is, it basically undoes a number being squared. So the square root of 4, since I look at the square root of 4 being the square root of 2 times 2, since I have a pair of these, this is going to equal 2. It basically undoes a squaring. So if I look at 3 squared, which equals 9, I can say that the square root of 9 is going to be like the square root of 3 times 3, so it undoes the 3 being multiplied by itself and gives me an answer of 3. So if I was to basically then imagine, in a sense, taking the square root of this, I'm going to get back this base. So if I do 1500 being squared, I'm going to get some number. And then if I want to take the square root of that number, whatever that value is, I'm going to end up back with the 1500. Okay. These numbers that I've been coming up with, the 4, the 9, okay, if I was continuing on to 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. Okay, these numbers are all of what are called perfect squares. The reason being is because when I take the square root of any of these numbers, the square root comes out evenly. Or the square root is a whole number. Sometimes I'm not this lucky though. Let's take, for example, what if I asked you what the square root of 13 was? Okay, it doesn't come out evenly. It will not come out evenly. But if I take a look at the 13, if I think, what are the perfect squares? Well, if 2 squared is 4, 3 squared is 9, 4 squared is 16, and if I was to picture putting these numbers on the number line, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and I can picture keep going. Okay, where would 13 be on the number line? 10, 11, 12, 13. So this would be 13. Okay. Where is this in relation to the 9 and 16? Well, it's pretty much right in the middle. Well, if I start picturing what the square root of each of these numbers is, well, the square root of 4 is 2. Square root of 3, or square root of 9 is going to be 3. Square root of 16 is 4. So what does that mean about the square root of 13? Well, it would have to be midway between 3 and 4, maybe a little bit over. So I'd picture it being something like 3.5 or 3.6. So let's check. Well, if I check 3.5 times 3.5, because remember, I'm looking for what number times itself would equal 13. So if I multiply these, 5 times 5 is 25, carry the 2, 5 times 3 is 15, plus 2 is 17. Okay, put that 0 there. 3 times 5 is 15. Carry the 1. 3 times 3 is 9. Plus 1 is going to be 10. If I add these, 5, 7 plus 5 is going to be 12. Carry the 1. It's going to be 12, 1. And then it's going to be 2 decimal places, because I've got 1 decimal place, 2 decimal places, so I have to have 2 in my answer. So I get an answer of 12.25. Pretty close, isn't it, to 13? Okay. Let's try the 3.6 times 3.6 to see if I can get any closer to 13. So if I multiply these, see what I get for an answer. I get 12.96, even closer to 13. Remember that 13 is my goal when I multiply these. So therefore, I would say 3.6 is probably going to be my closest. I could try 3.7 as well, but it's probably going to be farther away than 13. Okay, so this is basically how I go about estimating what the value of a square root is when the number underneath the square root is not a perfect square. So hopefully this has been helpful to you. Tonight, what I'm going to ask you to do is to go ahead and try on page, actually I'm not going to even ask you to try any, so we'll please come in with notes ready, and then tomorrow we'll take a look at some examples and have you work on some. Okay, have a good evening.